As you all know that we have started the second chapter of physics, and we have studied about magnets, properties of magnetic field lines and their properties, and magnetic field due to current carrying conductor, right hand thumb rule, due to magnetic field due to a circular loop, solenoid, electromagnet. So today we will move forward to our next topics. But before I start the next topic today, let us talk about magnetic field due to current carrying conductor. When we discussed this topic, that magnetic field due to current carrying conductor, what we discussed that when a magnetic compass was placed near a conductor carrying current, the needle was showing deflection. That made a conclusion that a conductor carrying current has a magnetic field around it. So there was a scientist who suggested that reverse can also happen. He meant that if a current carrying conductor produces a magnetic field and exerts a force on a magnet, then a magnet should also exert a force on the current carrying conductor. Now for an example, if an aluminium rod is suspended horizontally by a wire between the poles of a horseshoe magnet and current is passed through the wire, it was observed that the aluminium rod is displaced. Now if the direction of current was reversed, the direction of displacement was also reversed. This was the observation of this experiment, and it proved that a magnetic field can exert force on a conductor carrying current. Now the question is how to find direction of the force. Now to find direction of force in such case, we have a new rule that is known as Fleming's left hand rule. It states that if we hold our thumb, forefinger and middle finger of the left hand such that they both are perpendicular to each other as shown in the diagram. So we have to adjust our fingers, these thumb, forefinger and middle finger, such that the forefinger is pointing in direction of magnetic field, the middle finger points in direction of current, then the thumb will show direction of force. You have to remember that you have to use this with only left hand. Now I will tell you a trick to remember these names, these words: force, magnetic field and current. You can learn it by father, mother, child. Father means force, F. Mother means M, that is magnetic field. Child means C, that is current. Now how we have to apply this formula, or how we have to apply this left hand rule to find direction. For example, just see the first picture given in the slide, that there is a conductor in between the magnetic field. There is a two magnets in which it is placed. Magnetic lines are from north to south. So just assume that direction of current is downwards. Now you have to take out your left hand such that your forefinger, your middle finger and thumb are in which direction? Are in perpendicular to each other. So if they are perpendicular to each other, you will adjust your forefinger such that it points in direction of magnetic field. Your middle finger in direction of current, that is downwards. So forefinger in direction of magnetic field, that is from north to south. Your middle finger in direction of current, that is downwards. Now just check your thumb. Is it going upwards or downwards? If you apply this rule by seeing this diagram, you will find that your thumb is pointing in direction of upward. It is pointing in upward direction. That means this wire or this conductor would be deflected upwards. So by using this rule, you can find direction of the conductor when it is placed in magnetic field.